Use algebra to prove that the square of any natural number is either a multiple of 3 or one more than a multiple of 3. So for these kinds of questions, it's often useful to break down the numbers that we're considering, in this case natural numbers, to be either even or odd numbers. So we can consider, for instance, 2k plus 1 to be all of our odd numbers and 2k to be all of our even numbers, where k is a natural number meaning positive integers. So if k were 1, then 2k minus 1 would be 1, 2k would be 2. If k were 2, this would be 3, this would be 4. If k were 3, this would be 5, this would be 6. So basically, these two expressions here, for all natural numbers of k, will represent all positive integers. But if we were to square these two things, if we squared 2k minus 1, we end up with 4k squared minus 4k plus 1, and this becomes 4k squared. Neither of these two things are easy to express as a multiple of 3 or one more than a multiple of 3. The easiest way to do that, to get a number which we can express as a multiple of 3 or one more than a multiple of 3, is if we can factorize out 3 from at least part of the expression. If we wanted to show that it's one more than a multiple of 3, what would be ideal is if we can factorize out 3 from the first part and then we have plus 1 at the end. So multiple of 3 plus 1. This isn't working. The instinct is right if you're to think of breaking up the numbers into even and odd numbers. That generally works for a lot of proof questions. For this one it doesn't. We want a slightly different approach. If we're looking for multiples of 3 or one more than a multiple of 3, then it's better to base our numbers around multiples of 3. What I mean by that is, consider 3k minus 2, 3k minus 1, and 3k. Again, this is a way of representing all positive integers. So if k is a natural number, if k were 1, this would be 1, this would be 2, this would be 3. If k were 2, this would be 4, this 5, this 6, and so on. So we can represent all natural numbers in this manner. If we were to square what we had here, then we would end up with multiples of 3 coming out in our expression. So let's look at this one first, 3k minus 2. 3k minus 2 squared is equal to 9k squared minus 12k plus 4, which is the same thing as 9k squared minus 12k plus 3 plus 1. And then we can factorize out 3 from the first three terms. 3k squared minus 4k plus 1 in brackets and then plus 1 at the end. That's a multiple of 3 plus 1. And that is one of the things that we wanted to show the square of any natural number would be, a multiple of 3 plus 1. Now we can look at 3k minus 1. Square this out, we get 9k squared minus 6k plus 1. Factorize out 3 from the first two terms, 3k squared minus 2k, close brackets, plus 1. That's again a multiple of 3 plus 1. And finally, 3k all squared is 9k squared, which is 3 times 3k squared. That's a multiple of 3. So each of these three things, they represent all natural numbers, for k is a natural number. When we square them, we end up with a multiple of 3 or one more than a multiple of 3. And therefore we have proved that the square of any natural number is either a multiple of 3 or one more than a multiple of 3. So let's just write a brief conclusion to finish off. 3k minus 2, 3k minus 1, 3k, for k being a natural number, represent all natural numbers. The square is a multiple of 3 or one more than a multiple of 3, proving the statement.